Miss Parent here again with horizontal problem number 2. This one's a little bit tricky. I have a small child here with a mass of 15 kilograms sitting on a merry-go-round or a carousel. And this particular ride, they sit down, and so friction is involved because I have a coefficient of friction, but there's also a rope for them to hold on to, which means that the arms can apply a tension in the rope. Okay. The radius of the ride is 1.5 meters and the speed of the ride is 10 revolutions per minute. Okay? And I want to know what the tension in the arms is so that the child does not fall off the ride. Okay? So the first thing I should do is draw a free body diagram. And as I've said, there are two helping forces in this case. I have the tension in the rope and I have friction from the ground, from the child and the merry-go-round. Okay. Then again, I'm always going to have Fg, and I will also have Fn. But those are perpendicular to the radial circle, so they don't do anything in terms of helping or hindering. Okay. The other tricky part about this is that the speed is given in revolutions per minute. Now I have to convert that to meters per second in order for this to work. And so in order to convert from revolutions per minute to meters per second, I need to know that V is equal to d over t, or the distance it travels over t. And the distance the child travels is the circumference. And the circumference is 2 pi r. So this would be 2 pi r times the number of revolutions, which is 10, divided by the time. So that's 1 minute, which is 60 seconds. And so when I multiply this all out, I end up with a speed of 1.57 meters per second. Okay. And now I can work with the forces. So again, because this guy's moving in a circle, I know that I have F net equals m, and I'm moving in a circle, so it's AC. And F net is my helping minus my hindering. So my helping forces are tension and the force of friction. So I'm going to have tension plus the force of friction equals m, and AC is v squared divided by r. Okay. And I want to solve for tension, so I'm going to expand this out. So I have tension plus the force of friction is mu, and because the child is sitting on a horizontal surface, mg is Fn. So mu Fn equals m v squared over r, and then I get tension plus mu mg is equal to m v squared over r. Okay. So I'm going to subtract mu mg to the other side, so I get tension is equal to m v squared over r minus mu mg, and now I'm going to plug some numbers in. So I get tension is equal to 15, V is 1.57 squared, R is 1.5 meters, minus 0.15 times 15 times 9.8. And when I do this math, I get tension is equal to, this turns into 24.65 newtons minus 22.05 newtons, which gives me a final tension for the child is 2.6 newtons to exert on the rope. And that's it.